Hello, everyone, and welcome to our session Beyond Shifting Left, Adopting a Frictionless DevSec Experience in the Age of AI. The term frictionless is something we hear a lot, but what does it actually mean for developers and security teams on the ground? It's about empowering development and moving past security as a roadblock, a source of tickets, and a cause for late cycle fire drills. But before we jump into it, my name is Brendan Hahn. I'm a senior product marketing manager here at Snyk. And today I'm joined by my colleague, Jeff Anderson, who is our product leader for all things developer experience. On behalf of both of us, thank you for joining today. We are thrilled to have you here at DevSecCon 2025. And today we're going to show you how a truly developer-first approach can make security a natural part of your workflow, not a disruption to it. Here's a quick look at our agenda. We'll start by talking about the massive speed boost development is getting from AI. Then we'll dive into the friction problem that this speed creates for traditional security tools. From there, we'll introduce Snyk's frictionless vision for what developer-first security looks like in practice. Jeff will then jump into an amazing demo to show you this in action, and we'll finish up with a recap and a look at the business impact of this approach. One of the themes from DevSecCon today is that development is in a new era of speed, and AI is the engine driving it. From copilots and chat interfaces that generate code in seconds to AI native IDEs that understand a developer's intent, the velocity of innovation is staggering. This isn't just about writing code faster. It's about solving problems and shipping value at a pace we've never seen before. But this new speed puts immense pressure on every other part of the development lifecycle, especially security, to keep up. And that's where the friction comes in. Traditional security tools simply weren't designed for this new reality. Instead of being smooth guardrails on the highway, they act like jarring speed bumps. They force developers into late-stage testing cycles, require manual reviews, and generate noisy scans that lack the context of the code being written. They break the flow, kill momentum, and turn a high-speed process into a frustrated crawl. And it's important to remember why these tools operate this way. Many were designed for a different era of software development, a more linear waterfall world where security could be a final gate before a monolithic release, but that's just not how we build software anymore. In today's iterative CI/CD driven world, these old models don't just feel outdated. They actively work against the speed and agility that modern development teams strive for. And this isn't just a feeling. The data shows a clear and concerning trend. AI tool adoption is nearly universal. 96% of dev teams surveyed by Snyk are using them. But here's the catch. Almost 92% of those same teams admit that AI is generating insecure code at least some of the time. And this leads to very real consequences. A recent study showed that 72% of organizations have already had at least one production incident caused by AI-generated code. We are building faster, but we're also introducing risk at an unprecedented rate. This friction and risk manifest as real costs to the business. Imagine you're a developer deep in the zone, solving a complex problem, and you're about to crack it. Suddenly, you get a notification from a security tool about a critical vulnerability. You have to drop everything you're doing, switch your mental context, log into a different UI, try to figure out if the issue in a transitive dependency you've never heard of is even a real threat to your application. By the time you determine it's not reachable and can be deprioritized, your concentration is gone, your afternoon is disrupted, and you've lost the thread of your original work. Now, multiply that experience across your entire team every single day. That's the true productivity cost of friction. The sheer volume of late-stage alerts and false positives creates analysis paralysis, slowing down release cycles, and finally, and maybe most importantly, it damages the culture. It creates a dynamic where security is seen as the team that always says no, leading to blame, burnout, and a world where development and security leaders churn from your organization. So what's the solution? We believe it requires a fundamental shift in how we think about security. It's not a gate, it's a partner. Our vision is to embed security seamlessly across the entire development lifecycle, from the first line of code generated in the IDE through the pull request into the CI/CD pipeline and all the way to production. When security is an intelligent, automated layer within the workflow, it becomes an enabler, not a blocker. So let's make that vision concrete. Today, we're going to show you what this looks like in the two most critical places for a developer, in the IDE and at the pull request. You'll see how developers can find issues, focus on what's new, and get AI-generated fixes that are tested to ensure they don't break your app. To further set the stage and show you exactly what this looks like with Snyk, I'll hand it over to Jeff.
Thanks, Brendan. Hi, everyone. My name is Jeff Anderson, and I'm part of the product team here at Snyk, overseeing developer experience. And I'm going to walk you through how we provide a frictionless security experience for developers. Engaging developers with security tasks can be difficult. You're asking them to step outside of their day-to-day focus of building and improving software to look at specific vulnerabilities and connect with DevSec tools they don't regularly interact with. As Brendan mentioned, in the age of agentic software development, more code is being generated at a faster rate than ever. Traditional security gates can't keep up with the volume, nor do they provide enough context for developers who are playing the role of human in the loop, which means shifting left is more important than ever to counter those challenges, and the experience needs to be seamlessly integrated wherever the developer is writing or generating code. It needs to be actionable, providing developers with the necessary context and tools at their fingertips to effectively triage and resolve security issues. And developers have an expectation of a consistent experience when interacting with the same tool across multiple interfaces. So let's take a look at a few ways of how Snyk provides such a frictionless experience. So here we have Visual Studio Code with Snyk's IDE plugins. And these IDE plugins pair with developers in their coding environment to provide context and actionability as they write their code. Our plugins help developers quickly find and fix vulnerabilities that are introduced as they're working. As you can see here, we have a sample project, and there are 18 total vulnerabilities identified across Snyk code and Snyk open source. However, if I'm a developer, I'm focused on what I'm doing today. I'm focused on my current branch and the contributions I'm making towards that feature. So it can be overwhelming to see all of the issues that have been identified across my repository. And that's why Snyk provides an easy to access toggle for developers to narrow down the security findings shown in their IDE plugin to specific items relevant to their branch and the feature that they're implementing, which enables them to focus on the newly introduced security risks and tackle them before they actually enter the build pipeline. And so we can see here that we've gone from 18 total issues to 2 code security issues. Once those findings are identified, it's essential for developers to understand why the issue matters, how to resolve it, and then be able to quickly adjust their code to address the vulnerability. I'll click into one of the code security findings. Snyk's IDE plugins provide a wealth of context about identified issues, including relevant CWE information, severity and priority scoring, along with in-depth analysis of fix advice, the data flow for the vulnerability itself, and a comprehensive explanation of what the vulnerability is. Along with the issue overview, we also have links to Snyk Learn, where users can learn about the vulnerability's background, the risk factors, and different strategies to mitigate or eliminate them. They're just one click away. And here in Snyk Learn, we can go through section by section, build our knowledge about this particular type of vulnerability, and then take a quiz to verify that we've understood everything that we've just learned. While a ton of context is available at a glance, your developer may want to cut straight to the point and fix these issues directly in their code, whether that's through the new knowledge that they've just gained through Snyk Learn or using the assistance provided in the plugin itself. With Snyk Agent Fix, developers can generate a fix suggestion on the spot, automatically providing a secure code implementation that will resolve the vulnerability and can be integrated directly in the code base with a single click. You just simply click Generate AI Fix, and Snyk will create multiple options for suggested fixes. As you can see, it's creating a representation of the code, parsing information about the vulnerability, and then making some recommendations. It will return those options. As you can see here, we have 3 examples. Once you've reviewed the suggestions, you can apply the one that best fits your project. This one's fairly straightforward, so I'm going to scroll down and hit the Apply Fix button. This makes a change directly in my code, and I can save the file and have Snyk automatically scan the changes again. From here, we see that there's now only one issue identified in my code. So once the branch is ready to be reviewed, developers will typically open a pull request and begin the code review process. So I'm going to hop over to GitHub and show you the process of opening a pull request. With Snyk's new pull request experience, we provided all of the same context and actionability found in the IDE, but now in their code review workflow on the SCM. So let's open this pull request. We can see that once the pull request is opened, the PR checks will start running. And this is where Snyk will automatically scan any newly introduced code as part of a pull request for issues that have been identified. And that makes them a strategic point of enforcement because it's gating developers from introducing this change to your production code. Once the scans are complete, we can scroll up and have a look at the review that has been added by the Snyk integration, where we first have a summary comment that shows how many issues have been identified and breaking them down by severity and from which checks they've been identified. And then for the Snyk code findings, we're able to actually provide an inline comment at the source of each issue that provides the same context that you would have seen in the IDE plugin. So let's have a look at this one. We have the same severity information, priority, links to CWEs, as well as the data flow information that we found in the IDE. And each comment has available actions like Snyk Agent Fix. With Snyk Agent Fix, we're able to actually run the Snyk Fix command as a reply. And Snyk will run the same AI-generated fix generation process to make suggestions on how to remediate this vulnerability. When I refresh the UI, you'll see that Snyk's acknowledged that we are requesting fixes, and it's working in the background to make those suggestions. When we refresh again, our suggestion is available. And so we can see that there's up to 5 fix suggestions available. I can review this and understand kind of how it's addressing the issue and decide whether I want to include this change or request another. If I want to see a different option, I can simply run the Snyk Fix command again. However, if I'm happy with this one, I can run the apply. When I run the apply command, Snyk will work in the background to make a commit suggestion directly on this pull request, which we'll see pop up. And then the Snyk PR checks will run again to verify that the changes implemented have not introduced any new issues. And voila, all the checks have passed and we're ready to merge our change. So that's what a modern developer-first security experience looks like. No context switching, no complex dashboards, just clear, actionable security intelligence delivered directly into the workflows that the developer already lives in, the IDE and the pull request. We're providing more than security findings. We're helping your developers understand the context of the vulnerabilities identified and help them easily remediate them either directly or using tools like Snyk Agent Fix. Developers will become security champions without ever asking them to leave their workflow, enabling them to develop fast and stay secure. Back to you, Brendan.
Thanks, Jeff. That was a perfect illustration of security and flow. What you just saw is how we move from a theory of a seamless, actionable, consistent, and empowering experience to real practice. In the IDE, developers get immediate feedback, can focus on the new issues they're introducing, and can remediate with a single click using AI. That same seamless experience carries over to the pull request, where teams can collaborate and fix issues with inline, actionable advice and generate and apply fixes. It's security that works at the developer's speed without interruption. And when you bring security into these moments, the entire experience changes. So what does this all mean for the business? It really boils down to 3 key outcomes. You accelerate delivery. When developers spend less time chasing down security issues, they spend more time building features and shipping value. You reduce risk by making security an early and easy part of the process. You ensure that more secure code makes it to production. And finally, you improve the developer experience. Taking the pain out of security increases developer satisfaction and helps you retain top talent. It's a win-win-win. And ultimately, these three impacts lead to a more profound change, a shift in mindset. When security is no longer a source of friction, it stops being a them versus us conversation between security and development. It becomes a shared responsibility and a common goal. Developers are empowered to own the security of their code from the start, and security teams are freed up from chasing down minor fixes to focusing on the truly complex threats. You can build a secure development practice. This collaboration partnership is the true promise of frictionless DevSecOps, and it's what allows you to innovate confidently at the speed of AI. But we're not stopping there. The prevention workflow that Jeff demoed beautifully is just one way Snyk is removing friction from the developer experience. In other sessions today, you can learn about how this frictionless vision is always evolving and how Snyk is continuing to innovate across the entire software development lifecycle. This includes securing AI-generated code at its very inception with the Snyk MCP server, using the speed and accuracy of our engines combined with the power of AI to find and automatically fix issues. It means helping you prioritize even more efficiently by understanding the mergeability or the risk of breakage when upgrading a package with Snyk open source. And it means empowering you to elevate security from task management to strategic governance at scale across your entire organization with new features like the ignore approval workflow. Now, I'm biased, but I'd highly recommend checking out these other sessions today. And that brings us to the end of our time here today. We hope we've given you a clear picture of how a frictionless developer-first approach can help you move faster and stay secure in the age of AI. Thanks for your time.